Hello, everyone, and thanks for joining us today. My name is Alexandra, and I will be your webinar host, which means I will be handling all of your Q&A. During the presentation, we have enabled the questions panel, which you should see at the bottom right-hand corner of your screen. You may need to push the plus sign to expand the panel. This session is being recorded and will be made available for all attendees should you care to listen to it again or share it with colleagues. Now, I would like to introduce our speaker for today, Mark Henry, who will present how to improve network performance by 50% every month. Mark, take it away.
Thank you very much, Alex. Hello and welcome, everyone. My name is Mark Henry. I am a senior engineer with Opie North American office located in Charlotte, North Carolina. A little bit of housekeeping to expand on what Alex presented. Everyone is going to be on mute during the presentation. What we'll do is following the presentation, we'll open up for a Q&A session. I'll bring everyone off mute. Feel free to just open up, ask questions. We'll do a walkthrough and be a bit more interactive. Topics for today, we're going to cover 4 high-end pieces. We're going to try to drill in as far as we can. The concepts are how to remediate your network events to reduce background noise, how to focus event automation on troubleshooting and repair, how to leverage trending data to reduce false alerts, and how to monitor configuration changes to reduce downtime. And all what we've found is if you can take yourself from a reactive to a proactive approach in your network monitoring, if you can work on reducing that background noise and identifying troublesome devices, poor circuits, poor installations, etc., then you can improve the overall quality of your end user experience, how well they're accessing applications, how well they're doing file transfers, how well they're able to download, send emails, or do VoIP-based phone calls. If you can focus on those types of things a little bit every day or a little bit every week, over the course of just a 30-day period, you can actually reduce all of your background events, and that of course increases or improves the quality of the experience and the way your people interact with the network itself. So let's talk about just a small sampling of what causes poor network performance. Obviously, this is just a very small subset. If you just simply Google poor network performance or causes of poor network performance, you'll find blog article after blog article that keep repeating kind of the same 4 concepts in addition to some outlier pieces. But those really start around the concepts of either poor network design and architecture, which leads to overall system congestion, insufficient hardware and bandwidth capacity as usage grows. So of course, a network was architected for a certain load, and then over time usage grows and investments aren't being made to expand the hardware and bandwidth that you have. Third, kind of on that list of top ones, actually are poor cabling selection or installation, resulting in high error rates, high discards, slow data transfers. And the fourth one in the, I guess you would, the top causes of network performance are unauthorized user activity. So users eating up your bandwidth, tying up your network resources with things like Netflix, peer-to-peer file sharing, Facebook, and all of the different games and chats and types of things that that can come with that kind of social application. So in today's piece, we're going to focus on a multi-layered approach in looking at solutions. So we're going to start with Optech's NMIS or NMIS platform, which is our free and open source performance and fault monitoring piece. We're going to focus on that to begin with. We're going to talk about how to use that and how to leverage the information in it to improve your overall network performance. We're going to expand on NMIS with Opie Events, which is designed specifically for high-end event processing. So it does correlation, deduplication, but also does operational automation. So Opie Events allows you to respond and react to events in real time. We're going to talk about Opie Trend, which is Optech's trending and analysis module. It's a predictive analytics engine, really. What it does is it looks over a period of time, determines what's normal for a piece of equipment on a day-by-day and hour-by-hour window, and then tells you if the activities on that device are not normal. So we're going to talk about how to use that as well, and we're going to talk about how to use Opie Config for configuration and compliance management, but specifically how to use Opie Config to monitor and alert on device configuration changes. Just a quick view of Augmentics application flow. We're looking at it from a two-tiered approach. With our commercial modules, you can actually take multiple NMIS servers and spread them out horizontally, so you can scale horizontally. You can deploy as many NMIS servers as you want across your architecture. They can collect from all of the subnets and devices that are under their purview, and then move that information up to a master level server, and you can have one or more master level servers. In all of the discussions that we'll be doing today, we're going to be focusing on the concepts of gathering and responding to information at the polar level. So even if you're just using NMIS on an individual server, everything that we do today is absolutely applicable. It can all be done at that single server. If you are scaling out your implementation, if you have multiple NMIS servers, even if they're not connected together using OPHA, Augmentics High Availability module, even if you're not connecting them all together, this can still be applied to those individual servers that are out in the out in your environment. So what we're going to do is we'll be shifting back and forth between this PowerPoint and our demo server to talk about the different pieces. So first off, what we'd like to do is we'd like to focus in on, again, NMIS, which is the performance and fault management module. It's the piece who's actually acting as the administrative module. It's doing all of your collection, all of your polling. It's handling all of your thresholding and your basic fault escalation as well. So we're going to focus on this piece, and we're going to start taking a look at some of the different reports that are available, some of the different panels of information that are available. And the first one we're going to look at is the top 10 report. So for those of you using NMIS now, this is probably a familiar screen for you. This is the default dashboard that opens when NMIS is set up. I'm going to close out the event log and the network metrics and health panel, as well as the metrics, the quick search, and NMIS community. So I'm just closing these pieces out to make it easier for us to open a few panels at a time. And what I'm going to select is reports, current, top 10. So one of the things that I like about the current top 10 report is it allows you to select a period of time in the top left corner. In this case, we happen to be on a day. It'll give you the window of time. You can also manipulate that manually if you want to. And then as you scroll through, you'll see that you have 10 nodes by average response time, average ping loss, CPU. You'll notice that many of these are focused only on certain types of devices. So for example, this CPU load is routers only. And then percent processor memory, IO memory, on down to percentage utilization for interfaces, interface traffic, etc. So when it comes to improving the performance of your network, what we're looking for is not reacting just to the events as they occur. That process still needs to happen. Someone needs to be receiving escalation. Someone needs to be looking at the performance information in real time and troubleshooting and understanding what's happening across the network for those types of events. When you're looking at improving the performance of your overall network, what we're talking about is the ability to look at the information that's being gathered by NMIS in a way where you can kind of analyze it scientifically and then take proactive action to reduce the impact or the negative impact of that event or of that performance, that operation, that device over time, so that you can improve how that device works and how it responds and interacts as part of your overall architecture. So the concept here in working with the top end panel, what we normally advocate for when we're training operators to utilize our solutions is to have someone work either on a daily or a weekly basis, or even in a combination of those, some items being done daily, some items being done weekly, and carve out perhaps an hour or an hour and a half of an engineer's time every day to open up something like the top 10 panel, come in and take a look at the top 2 or 3 offenders in each of these categories, and then try to determine what's the causal factor. Is that acceptable? Is it normal operation for that specific type of device? And then if it's not, to figure out how to remediate that. What's causing it? So for example, in the top here, you'll see that we've got average response time for several of these devices. And let me just blow that up a little bit. There we go. Pardon me. So you'll see under average response time for several of these devices, it has a very, very long response time. Now, there are a lot of factors that can cause long response. The device itself may be overloaded, may be overtaxed at this time, or within this window, this 24-hour window of time. It may have been overtaxed for whatever reason, but it also could be configuration related. It could simply be the speed of light issue, where the NMIS server has to be able to communicate with the device. The device may be geographically or even logically very far away. And so it takes time for that device to respond to a ping. So again, it's taking the time to look at these and understand what the causes are. And quite simply, all I would do is I would drill into the device and I'd start looking at the performance data of that device. Where is it in memory-wise? Where is it on CPU? How much data is moving through its various interfaces? Does it have errors and discards? And looking at that type of information to understand why it's loaded. And I would do this for each of the top 2 or 3 items in every class and category under the top 10. If you don't do anything else in trying to move from a reactive proactive standpoint, it would be starting with the top 10, and again, either once a day or once a week, pick the top 2 or 3 items in each category and try to understand why they're in that top 2 or 3. Is that normal? So a good example of understanding what's normal would be looking at the CPU load on these 10 routers. So this CPU load is all within a couple of percentage points of itself. So 26.27 up to 28.87. These all happen to be software-defined networking devices. They're all the same class of software-defined networking devices, and they're all operating within a 0.5% or 1% of each other. So I would look at that, and I would consider that normal operation. Same thing for percentage of memory used, within a couple of percentage points. But then we could look at I/O memory used, and you'll see that this changes dramatically. So you see right here, there's a cutoff point. These bottom 4 are all, again, 20 to 22%. These ones up here, these switches, these guys are all up to 67, 68. So I'd want to look into those switches, understand the model operating system that's on it, where it is logically as part of my network architecture, and then try to determine, is that normal for those devices? Last thing we'll look at under the top end, I'd want to look at my my interfaces by percent utilization. Again, this is just our demo network, so there's very low internet utilization for all of our interfaces here. But I'd still want to take the top 2 or 3 and want to break those down and understand what kind of traffic is routing through those, why those interfaces are running at the level they are, and if that is normal or not. So the next thing that we're going to take a look at is the network performance top 10. Now this is subtly different from the reports version. Network performance top 10 from the menu. And for those of you following along, I have uploaded the PowerPoint that we have here under the handouts panel in GoToWebinar. So you can go ahead and download that and have that with you. And it has all of the links, all of the menu links for each of the products is in that PowerPoint template. So you can go ahead and open that up, and then you can follow those pieces through. So very, very similar to the reports top 10 panel. Again, layout's a little different. If you open them side by side, some of the things that you'll notice is under the reports top 10, many of the categories are restricted by specific types or classes of devices. So, for example, I mentioned that some of the categories are restricted to routers only under the reports top 10 menu, where this top 10 menu doesn't have that same restriction. So you'll get routers and switches and firewalls, and they'll all be kind of jumbled together in one lump. And I would do the same process here without duplicating effort, of course. So if I've already remediated CPU load, I would not, again, remediate CPU load here on this panel separately. The next piece I'd look at is the events, the types of events, and what devices have the most events. So with that, I'll open up the service desk. Service desk alerts events. So this is my current event tree. Everything, all the open events that are happening across this polling server. This is all broken down and grouped by device. So, for example, the first two events or first two event rows here are with Asgard, which is a small iOS device. We've got alert BGP peer down. It's a warning level of event. And so I'd want to understand what's happening to the configuration of this device. How long has this event been going on? What caused the event? And then again, want to work on, even if it's just marking these as acknowledged, and then clearing those events out from the event tree. In a moment, we'll take a slightly different view on event management. When it comes to remediating events, NMIS does a fantastic job of organizing and handling individual events. So NMIS's thresholding and escalation system works on each individual event on its own, kind of in its own encapsulated little world, without really looking at what else is happening across that device or across the system. We're going to take a look in a moment at Opie Events and its daily reporting capability and see how it can provide additional analysis. But for now, again, it's looking at the devices with the most events. So unfortunately, in this panel, I can't organize this. I can't swap it out or sort it by the total number of events. So I would scroll through. I would look for critical events. Want to make sure that they're being handled by the team on a proactive basis. I'd also want to look at devices with a large number of events. So Eris, for example, has 4 events that are open for it currently. We've got the Hell server, 6 events across that, and I'd want to work and remediate on these and get these cleaned up and closed out, or make sure someone was at least responding and some activity was being done and some research was being done for each of these pieces. I know some of what I'm saying and sharing with you today seems like common sense, but the fact of the matter is, depending on what your team's workload is, you may simply be stuck in kind of a responsive or reactive mode where you're so busy on projects and upkeep and maintenance and rolling out new pieces of equipment and responding to phone calls and emails and trouble tickets that it can become very, very difficult to refocus yourself and say, how can I use this information and take a little bit of a different stance. So again, just if you could carve out an hour, hour and a half, once a day, once a week, but do it every single week and focus on the top 2 or 3 issues under each of these, it can make a significant positive impact on your network performance. So the next thing we're going to look at is reports, current, collect, update time. So again, reports, current, collect, update time. Now this one is actually looking at how your NMIS polling server is collecting information from the devices that it's monitoring. So you'll notice that in this view, again, you can select your period, or you can adjust the dates and times if you want to. What I like about this view also is that I can sort on collect time or update time columns. So now I've sorted on collect time, and again, focus on the top. Each time you do this, focus on the top 2 or 3 items in each category. So if I looked at WMI collection on the Hell server, I've got the Manny server, and I've got regular SNMP collection on Hell. So I've got 2 different views, one by WMI and one by SNMP on that same server, and they're pretty long. And then everything else down here seems to be sub 7.5 seconds. So focusing on that top 2 or 3, you're always looking to remediate the things that are taking the longest time, using up the most bandwidth, and you're remediating based on the performance and improving the performance and the response time of that device. So I'm just sorting now on the update time. So depending on your cron schedule, generally speaking, NMIS ships with a pre-configured collection time of every 5 minutes and a pre-configured update time of, I believe, midnight plus 30 minutes for your server time. So again, update time, let's look at the top 3, and we've got WMI Hell and SNMP. So that server is responding slow for both of those. And then we have a small software-defined router, B&E Lab P2. So again, I would work on addressing those top 2 or 3 issues, and then hopefully the next time I run this report and I take a look at this, those won't be there. I won't have those issues anymore. I would have addressed those issues proactively. Those devices will be working better because of it, and I won't be seeing those issues again. The next one is going to be the node admin summary. So that's going to be system configuration check, node admin summary. System configuration check, node admin summary. And then up here in the top, in the dark gray bar, I'm going to select only exceptions. Again, I'm not, depending on how many devices are on your network, I've only got about 40 devices here on my little demo server. But if you've got an NMIS server holding 3,000 devices on it, you don't want to try to sort through all 3,000 plus rows. So I'm just going to go to only exceptions. And so now this is going to give me a lot of really great information, and it's all highlighted and colorized. So last collect poll, last update poll, ICMP working false, SNMP working false. So this router, B&E router, hasn't been talked to. Nothing's been collected on this router since 29 November. It hasn't been updated since 20 November. It's not responding to ICMP, so it's not responding to ping, and it's not responding to SNMP. So again, I would take my top 2 or 3 devices and start. Why is this not responding? Why has no one on the engineering team realized that this device is offline effectively? Has a set of credentials changed? Has my routing, has my NATing changed? Can I no longer reach it? Did someone change a firewall rule or a router rule, and now I can't get to that, or it can't respond for some reason? So again, every day, or at least once a week, just spend a little bit of time. In talking to network engineers, I have the privilege of talking to about 30 or 40 different companies, different businesses every week. A lot of businesses we work with that we help them in an ongoing basis after they acquire our network monitoring solutions, and they often say the same thing: we're overworked. It's very, very difficult to find time to do these types of things. We want to do it, but there's we can't find we can't carve out one resource just to do this. But my response to that is, if you don't take the time to invest in proactively improving the quality of your network, you're always going to be responding reactively to the fires that are happening, right? I'm very lucky to live in a location in the United States where our local fire departments actually go door to door twice a year and install fire and smoke alarms in homes and replace those annoying little rectangular 9-volt batteries that no one seems to have in the closet when the smoke alarm starts beeping at 2 o'clock in the morning. So those guys, those firemen know that by being proactive and installing smoke alarms in buildings, they will save lives, right? That smoke alarm is going to go off. Someone's going to be able to take care of whatever the problem is before the home becomes engulfed in flames and the fire department has to roll out. The last thing we're going to look at for NMIS is System Host Diagnostics NMIS Runtime Graph. System Host Diagnostics NMIS Runtime Graph. Now this one really talks about the polling server itself. This is the health of the polling server. There are a few other host diagnostics you should be paying attention to. Are all of your services running? Are they collecting properly? Are they responding in a good time? But this is your starting point. And the concept here again is looking at things like your total runtime. How long does it take for a collection to occur? If you're running a collection once every 5 minutes and it takes 7 minutes to complete a collection, your collections are never completing because the next collection will kill the remaining processes from the first collection. So looking at these types of things, looking at your collect time, your run time, your update time, how many processes are running, how many max parallel processes you have, and understanding the load on your NMIS server will help you determine if you need to adjust your collection times. So with NMIS 8.6.2G, we've just introduced the ability to create custom polling cycles and assign those to devices. So you might take devices that are overloaded or that are very slow to respond, or devices that have a lot of SNMP data to return that need more time, and have them on a slower polling cycle. And that'll help you complete your collection times, your collection cycles, rather than running over each other and then having NMIS kill those processes that haven't completed in time. So if you're starting with Opmantic's NMIS platform for performance and fault management, these are really the top 6 pieces we recommend that you employ. Again, if you can take someone and just carve out an hour, hour and a half of someone's day every day, or 15 minutes a day, or an hour once a week, do something. Take it as a process, take it as a daily activity. Come in every morning, take care of whatever fires have happened overnight, whatever events have occurred, and then carve out the hour before lunch from 10 to 11 or 10 to 11:30 a.m. just to do this kind of validation, inspection. Really dig into your system and understand what's happening. But this is just the start. This is step 1, right? If you're looking at implementing our commercial modules, so for example, if you're using Opie Events, which is really an advanced fault management, it builds on the thresholding and escalation system in NMIS and expands on it, providing correlation, deduplication, managing whitelists, blacklists, but also does operational automation. Opie Events can be invaluable in expanding on what you can do in NMIS. In fact, we have many clients who have turned off NMIS's escalation system and only use Opie Events because of the amount of clarity and especially, again, the operational automation level that Opie Events brings you. So in NMIS, we went through 6 different things to take a look at. In Opie Events, we're really going to focus on 1. So I'm going to go over to another panel here. And all I've done in Opie Events is I've gone from the dashboard and I've selected views, summary reports, and you can create a summary report either on a daily or a monthly basis. That's all configured in the opcommon.nmis file. Now here, what I like and what I often recommend we start spending our time on is top nodes and events by event count. So there's a lot of different report sections that are in here. This report can be emailed out on a daily or a weekly basis how often it makes sense, or you can access these reports right on your server. I like to look at it right on the server because all of these links are live. And so as I start drilling into a device, I can simply click on the device name, open up that device in either NMIS or OP charts, and take a look at that device live while I'm drilling through this report. So I like that perspective. But if we scroll down through here, you'll see that this report breaks down top 10 nodes by event count. So much as we talked about looking at the information provided by NMIS and addressing the top 2 or 3 things in each category, it's the same approach here. Right off the bat, we have one device, Manny, who created in the last 24 hours 151,000 events, or 94, almost 95% of the total events monitored and responded to by this server. I purposely don't remediate that on this server so that we can use that as an example. I've actually seen this type of event disparity in many customers that we talk to. Oftentimes, it's something as simple as a bad cabling job. Someone's re-terminated a cable, or maybe they've installed a cable of an older spec. Maybe it really required a Cat6 cable, but they've got a Cat5 installed, and they haven't terminated it properly, or they didn't test the cable, and there are issues with it. It could be very, very simple that a device is in an unair-conditioned closet somewhere. It's the middle of summer and it's too hot, and a fan on the device has gone down, and the device is overheated and is generating a lot of errors and discards. The only way you'll know, though, is by looking at it. Right? You have to start looking into these pieces. So if I did nothing else, today, I would want to understand what is happening on this one device, what kinds of events are occurring, and then understand how do I quiet those events, right? Do I need to be processing them, or do I need to reconfigure the device? The next piece is top 10 events by count. And this is actually, although it doesn't show it here, this is actually what's causing those events. So you'll see Windows Security Auditing, Task Schedule, and Windows Task Scheduler, again, a slightly different piece. Each of these, you start adding those numbers up, and that's a big part of what's causing that previous piece. So again, using information, event counts by priority. So we've got 159,000 priority 1 events, 99.8% of my events. But remember, a big portion of those are coming from just one device. So do those need to be there? And if these are all priority 1 events, what's happening with them? Someone needs to be remediating that. Someone needs to be looking into it. What's causing it? Is it a misconfiguration? Is it a hardware failure? And working on that information. Event counts by node and name. So this is why I like this one. This is the panel I really try to focus everyone in on. Again, the concept of remediating the top 2 or 3 items in each category. So here, you can see that the top 2 are both coming from that one server, Manny, Microsoft Windows Security Auditing, Microsoft Windows Task Scheduling. The third item is an SNMP v2 MIB authentication failure. So there's probably a bad SNMP community string, but we would look into that. And then the fourth item is also on Manny, so I might expand my day's work down to the fourth item, or I may simply say, today, I'm just going to remediate the problems with Manny. And then tomorrow, I would expect Asgard to be the number 1 and ODR to be the third item on my list tomorrow. Right? So each day as I remediate and I understand what these issues are, and how they impact, do we need to do something about these? How should I be responding to these? Can I reconfigure the device so it doesn't create these? Do these need to be created? Do they need to be responded to? Asking yourself those questions is how you end up improving the performance of your network. And it's also how you improve yourself as a network engineer as well. All right. So again, work the top 3 events and devices every day. You can also compare these events to either the NMIS top 10 list or the OP charts top N if it's available. So just taking a quick look at OP charts. This is the OP charts top N page. So if you go to views, top N, and we call it top N rather than top 10 because you can configure for OP charts whether it's 3, 5, 10, 15, 20 items in these lists. But we also break down the CPU load, top N utilization, error rates, discards, top N in and out, and top N memory utilization. So in most cases, these will match the top N in NMIS. Sometimes it'll be slightly different because again, the top N reports in NMIS are focused in many cases just on routers, where this will actually take into account all types of equipment. So router, switches, hubs, firewalls, and also servers. The next item we're going to talk about today is how to leverage Opie Trend. So in NMIS has built into it, NMIS has built into it a thresholding system, which is both a balance of dynamic but also fixed thresholding. And what I mean by that is that you may set an alarm in NMIS that if CPU utilization exceeds 80%, that you're going to generate an escalated event and you're going to respond to it. And you can set several different types of events for those, or several different types of thresholds, rather. And then you can escalate. You can respond to those different lines in the sand differently. What Opie Trend does is Opie Trend gathers information over time. So it looks at a day of the week. So for example, it'll look at Wednesday, and it'll look at 2 to 3 p.m. So an hour window of time on a specific day of the week over the past 26 weeks to determine what is normal for that device. And it'll do it for that device's CPU and memory, and then it will do it for each of that device's interfaces. So what's normal usage, percentage usage for a specific interface on an individual device on that hour window of that day of the week? Opie Trend will figure out what is normal. It'll then map that out for you. So let's take a quick look at what that looks like. So here we have one individual. In this case, it happens to be CPU load. And we can go ahead and zoom in on this, so a specific piece of time here. So you'll see here that we're getting a spike in certain time windows. And we can see how that black spike exceeds this blue control. So the green bar here is the mean, right? So for those of you students of statistics or mathematics in general, you've got standard deviation. So the blue lines are your standard deviations off your mean, and then anything that falls outside of that falls outside the norm. And so with Opie Trend, what you can do is you can tell Opie Trend that if you have 1, 2, 3, 4, 5 measurements outside the norm, to raise an event to NMIS. So what Opie Trend does is it augments NMIS's thresholding and escalation window by understanding what is normal operating procedure for a device. So the nice thing here is you can escalate for operations that fall below. So for example, in this case, this happens to be CPU, but it could very well be applied to interfaces as well. You could say if this falls below what's normal throughput, then raise an event for low usage, and if it rises above what's expected, then raise an event for high usage. The idea here, again, is that you can slowly migrate yourself as the system gathers more performance data about your devices, about your network. I would start with thresholding and escalation rules in NMIS, working with Opie Events, and then as I collect information in Opie Trend over time, I would then turn on the Opie Trend event creation. So Opie Trend then starts sending events to NMIS. NMIS processes those, either applies the escalation rules in NMIS or passes those events to Opie Events, and Opie Events would then use that information to raise an event, process the event, correlate, deduplicate, look for event flap, look for event trending, and then also automatically respond to those events and do something about them, right? Take proactive action on those events. Again, the concept here with Opie Trend is that if you allow the product to understand what is normal operational, then you can move away from those static levels, that line in the sand of 80%. You may have a series of devices, for example, Linux-based firewalls, which normally run very, very high on CPU. They can run anywhere from 96, 97, 98% CPU utilization all the time. And you wouldn't necessarily want those alarming, but you wouldn't want to suppress those alarms because they're normal. So instead, by using Opie Trend helps you understand that that's normal for that device to run at that level, and then it doesn't generate an alarm. So over time, as Opie Trend builds up performance information, and you turn on Opie Trend's event creation, you can actually turn off NMIS's escalation response to those static thresholds from NMIS. So you move from static thresholding to dynamic thresholding. So our recommendation with Opie Trend is you start trending with core devices. Now, Opie Trend is licensed as an all or nothing type solution. So everything that's in your system gets handled by Opie Trend. So what we usually recommend is that you set up an NMIS polling engine just to monitor your core devices and install Opie Trend on that one NMIS server, and then work from that point. Then you might have another polling engine, another NMIS server that's handling your edge devices, your VoIP systems, those types of approaches. So you can do SLA management using different types of NMIS servers. I strongly recommend that you let Opie Trend gather at least 45 days of information before you enable thresholding. The reason for that is, again, Opie Trend is looking at a specific day of the week and hour by hour window. And so if you have 45 days, you have 45 days, but you only have perhaps 5 Mondays from 1 a.m. to 2 p.m. or from 1 a.m. to 2 a.m. So you only have 4 or 5 samplings or of windows. All right, the last piece we're going to talk about today is Opie Config. So Opie Config is a very powerful configuration and compliance engine. What it does is you license devices from NMIS into Opie Config. Opie Config then reaches out via Telnet or SSH, connects to that device, executes CLI commands on that device based on the manufacturer, model number, and even operating system. So it executes CLI commands based specifically on that type of device, takes those the results of those CLI commands. So for example, show running config, stores them and compares them to the last version collected, determines if there's a delta. It then determines if that delta is important, right? Should that change be something that is alerted to, and then can raise an event to Opie Events that tells you, hey, there's a problem. There's an issue here. Something has happened. Someone has changed the configuration of this device. And then again, now that creates an event. The event can go through the escalation system. It can then notify someone, and you can even take automated response using Opie Events to that configuration change. So let's take a quick look at what that looks like. So for example, I'm just taking a look here at this little iOS router that we've got here. And I can see that I've got many events over this this past 90-day window. In the bottom left-hand corner, you'll see the events that have been collected. In this case, I'm just looking at show running config. And I'm going to pick this revision 199. We're going to take a quick look at that. So now this shows in line. I like to see it side by side. So I'm going to switch this to compare revisions. That's just going to show me in a side by side view. And again, all of these GUIs that I'm running through now, it's important to note that these pieces, they're very flexible. I can change these out easily. I can change which ones are default. I can change a lot of the layout that comes here. But I can also come in here and I can go side by side and understand what are the changes that have happened, how these affect this device. And I can look at each of these. Again, the green being the new version, red being the previous version. And understand exactly what the change was. And then we can determine, is that change important? And should event be raised from that? Now this is all automated, so Opie Config already comes understanding dozens of manufacturers, models, numbers, types of operating systems. It comes pre-configured with hundreds of CLI commands, again based on model, manufacturer, and the operating system involved. So for example, for Asgard, these are all of the commands that are being or can be executed against this device, and then you can determine which commands you want to collect on a regular basis. Do you want to collect them hourly, once every 4 hours, every 6 hours, once a day, once a week, and back up these commands? So this becomes effectively a backup of your device, right? So you can back up all of your configurations for your routers, your switches, your hubs, your firewalls, load balancers, everything across your network, all of your networking devices. You can back up all of their configurations, store them, alert on changes to those pieces, and then also at the same time, you can actually build out what we call actions. So you can back up a configuration of a device. You can break that configuration up at the command line and then store that configuration as a reproducible configuration that can be pushed back down to that device at the command line or on a schedule. So you can actually use Opie config to query, say, a golden image device, and then create new outgoing commands to configure that same model of device out in your architecture. But to focus back in on performance, the concept here would be, again, to start collecting on core devices and then expand that collection over time. Our system, again, comes pre-configured to collect on relevant commands, but you'd want to make sure that everything that you want done is being done. You don't have to necessarily collect on everything. And then you would use both detect change and raise change. To detect change would help you store commands based on changes, right? So you wouldn't necessarily want something like a time clock update to trigger the storage of a command, but you'd want to necessarily maybe change in your BGP tables, right? And you'll want to use raise change to raise an event in NMIS if something has happened. So if a change occurs and the change is important, someone has taken your encrypt password and turned it to false, from true to false, and so now your passwords are no longer encrypted on your device, then you can go ahead and raise an event for that. That can go to NMIS. It can be processed through NMIS's escalation system. NMIS can also pass it over to Opie Events. Opie Events can do something about that and take proactive response to that piece. All right, that concludes our webinar for today, at least the kind of the scripted portion of our webinar today. So what I'm going to do is I'm going to take everyone off mute. So you're welcome to join us today. Ask any questions you want. If you don't have any questions or you just want to listen in, you can put yourself back on mute if that makes more sense for you. It's totally up for you. We will also be making this recording available to everyone. So one thing I'm going to do is I'm going to go ahead and turn off the recording at this point. That way, any of you who are a little on the shy side and who don't want to have your voices